with 150 divided by 32.2 is equal to 4.658. Okay, pound mass. So now we are going to put everything into our characteristic equation. So the characteristic equation that we're going to do is we see how much we can assemble over here first, okay? So we know we need to apply mass x double dot dot plus by kx is equal to f naught sine omega naught t. We know that, okay? So the mass will be equal to 4.658 x double dot dot plus by a stiffness. So we have found that our stiffness is 1800 x, and this will be equal to f naught sine omega naught t. Okay, so we have that information now. So the next thing that we are going to find out, okay, we are going to focus on the right hand side of, I'm going to call this equation 1. Okay. Now, this f naught sine omega naught t is due to this. Come on, give me a few seconds. The f naught sine omega t is due to this. That is the cause of it, yes or no? Right? So we are no more going to focus on our structure, but rather we are now going to focus on the motor with the unbalanced mass. Okay, so this is what that is inducing the what? The force vibration. I mean, when I see a question like this at your age, right? If I don't go through stage by stage, it's really going to be really what? Confusing. Are we clear? So that's why I'm going extra slow, stage by stage, on which part to analyze what, why, and where. Are we clear? Okay. So from here, we are going to determine our F naught sine omega naught t. Let's do the easy part first. We now know, okay, from the motor diagram, right? From the motor diagram, okay, we know that omega naught is equal to 20 radians per what? Second. Why this is what? Given. Okay. The next thing is our F naught. Okay. So F naught is equal to mass times by acceleration. Okay, mass times acceleration. And we know, right, the acceleration seriously, Eugene, can someone spell for me acceleration? Acceleration. Is that right? Hey? Acceleration like this. You know what? Yeah. You know what? Too much math. Can't spell now. It's just like I'm tired for the day. And so it's embarrassing, okay? The angular, for this case, the angular acceleration. Okay. Okay. The angular acceleration formula. Okay. Why is angular acceleration? Because our system is what? The unbalanced weight is what? Rotating. Right. So this will be equal to R omega squared. Okay, so I'm going to put this is also equal to mx double dot. So we know the radius is what? 10 inch. And then now we know the weight, we have to convert to what? To mass. Okay. So F naught is equal to m r omega squared. By the way, I will provide this formula for now if this question were to come out, because you have not learned, or you have, some of you might have forgotten in high school. Okay. So the mass now is equal to 0.25 divided by 32.2, because we need it to be in mass. The radius is 10/12 because we are going to convert this to feet. Okay. And then the omega, which is straightforward, is 20 squared. Okay. So from here, 0.25 divided by 32.2 times by 10 to the power 12 times 20 times 20 is equal to 2.588. Okay, pound force. And then from here, right, so we know whatever is going on the right hand side. Okay, I think I will, as I've done this before, I'm going to call this omega naught. I don't want you to be confused. Okay. Yes. Yes, the force of the force amplitude of the arm, but is imposed by sine omega naught t frequency. So the amplitude is not constant. The force amplitude will be what? Oscillating. Okay. Any more hands been raised? Are you okay? Yes. F0 over here. Is it F naught? Oh, this one. Mass times acceleration. That's it. So the angular acceleration, I did mention, okay, I will derive this. Where? Come and point. Come. Sorry, I don't get your question at all.
How did you get this equation here?
Oh, it's just substitution. Sorry.
But wouldn't this be divided? Oh, okay. Wait. So you substituted this with F0.
Yeah.
Okay.
I know it's Friday, you cheeky soul. You okay now? Okay. Sorry, I did not understand what you're highlighting on. Okay. Right. So from here, we can immediately determine our. So now, where do we go from here? Okay. Where do we go from here? If we look at our transient state or steady state, the question asks us to find our stiffness. Did we find our stiffness already? The spring stiffness. We did find our spring stiffness, yes or no? So this is our spring stiffness we got. The next part is the natural frequency. So we find our natural frequency. So this is omega n, or natural frequency, which is omega n, and this will be square root what? K over m. So we know that our stiffness is equal to what? Our stiffness is 1800, and our mass is 4.658. Okay. So by calculator, so 1800 or square root of 1800 divided by 4.658 close bracket is equal to 19.658 radians per second. Okay, so we found our omega n. The next part of the question, we have to determine, okay, the steady state amplitude. Okay, so I'm going to go to the next page. I'll give you some time to write things down. Yes. Yes. Wait. That is F naught, not J. The full equation is what? Okay. So it's not a constant. If it's constant value, it's good. It will not vibrate at all. Yes. Very, very good question. All right. So for this case, the natural frequency is the natural frequency of the structure, not the natural frequency of the weight or of the motor. Are we clear? So natural frequency of the structure is your what? Is your simply supported beam. Are we clear? Does that make sense? Okay, that's why I'm doing this in stages. Because if I just lump the equation together, you're like, whoa, yes? Okay, I'm going to take it slow. Okay. Because I still remember this question when I was an undergrad. I just memorized things without knowing why. And I happened to, that caused everyone fail. Okay. I'll tell you why that caused everyone fail. So this is one of the courses I have to take in my final year. Okay. And everyone failed because on that year, no calculation. I stared at the professor during exam. I stared at him. I took my calculator, literally put into the bin in front of his face, and walked back to my seat. Everyone failed. But I got an A because all died. I did not die so badly. Okay. So when tests are difficult, don't like, oh, I can't do it, I'm going to give up. No, everyone dies. Are we clear? Okay, but don't die too badly. Okay, die, die nearer to the surface than die towards the ground. Okay, I should not saying things about death. Okay, especially it's Friday. Okay, so I'll put down here the natural frequency is looking at the what? The structure. The omega naught down here is what we call the induced frequency. The induced frequency over here, no need to calculate. Right? This is a omega naught is a parameter that should be what? Given. Okay? Whereas omega n is based on the structure, you have to what? Calculate. Are we clear? Okay. So now I think we have everything. Okay. So the next thing we are going to do now, right? We are going to look at the steady state. So I'm going to copy this whole thing. Come on, come on.